Now I am giving the presentation for instrumentation and drive system. My name is Suhas Shivaprasad Kubsad. So this is the layman schematic diagram. So we have light sensor and two LED lights and three ultrasonic sensors, and we have battery and DC motor, servo motor, Ackermann steering assembly, and master and two slave Arduinos.
We are using Tinkercad as an Arduino simulator. So this is the wiring part of the Arduino and this is the code we are writing. So we are using one master Arduino and two slave Arduino. These two slaves will be communicating with master Arduino, and we are using light sensor and we are using headlights, which light sensor will control the headlights, and we are having three ultrasonic sensors. So left, right and front. So front will control the car speed and left and right will control the car direction, and we have a micro switch. If it is acted, car will stop. So we have a DC motor, and this will be controlled by L293D chip, and we have a two batteries, 9-volt batteries, which will be powered up. So we have a servo motor, we have a magnetometer. So magnetometer we are taking as a potentiometer, which is acting as a compass. So now I will move on to the programming part. So we are defining the libraries and we are defining the variables here. All that we are declaring it. So here we are defining it. So here we are setting up all the variables and connecting it to the Arduino. So here we are like setting up micro switch, headlight, all ultrasonic sensor, servo motors and all. So now we are this code is for the communication between the master and slave for servo motor, that is slave 2. So these ASCII values, when we type in slave 2, so motor will servo motor will run to these angles. So we have six conditions we have used here. So now the communication between magnetometer, which is acting as a slave one. So this is the code we have written. So these are the magnetometer will read the values. We are using potentiometer here. So potentiometer will give the output here. So now the main loop will open. So here we are like using micro switch, so it's acting as a push button. If it is high, car will stop, or else program will run. So this is the code for the motor control. So this is the initially, like we are assigning the ASCII value 65 to 90, and in this range as to the potentiometer we are assigning it as per the potentiometer. So initially it will show 100 as we defined in initially here. So now these are the three ultrasonic sensors we used. So when if we start simulation, so we can change these values, change these values all the three, and we will get output right side distance, left side distance and front distance. So this is the code we have written for this. This is for front, this is for right and this is for left, and we are now we are defining the speed. So now like we are typing string n. So motor is running forward direction, so car is ahead. So if we are writing any ASCII value like 0, so it will take to negative and car will run in reverse direction. So car reverse, it will output will be minus 173. So this is ASCII value and this is the RPM. So now else it will map to brake. So now we are mapping the values here. So now I will show the communication between the this is the for the servo motor. So here if we taking the image from the MATLABs, like we are taking 1 to 6. So 1 to 3 for the numbers for the left and 3 to 6, 4 to 6 for the right. So if you type 2, servo motor will rotate towards this much angle as we defined before. So if you define 5, it will rotate this much angle. So if you type any number, it will come to the original position. This is the second slave. This is the master servo motor code, and now we are moving to another slave. This is magnetometer. This is the code we have written for the magnetometer. So here we are setting the address as 30, which is communicating with the master. We're sending the values here, transmitting the values. So ensure these values are positive and we're converting them to 2 bytes, and these values are transmitting to the master Arduino, this one. So third one, if we change this potentiometer, it's now it's in the south. Like when we change this to other side, this value will change, minus minus, it's at the south and it's towards east. So one positive and one negative. So magnetometer is working properly. So Now about micro switch, when you press this, we will get car stopped. When you release, again the program will run as it is. So now we will check for the light sensor how it is working and how it is enabling the headlight. So initially now it's less than 100 the range, so that's why both LEDs are on. So if it is greater than 100, so LEDs will switch off. So this is the logic we have used for the light level controlling. This is the conditions we have used.
Now we are using LabVIEW block diagram. So here we have three input from ultrasonic sensors which are taken from Arduino. So this is for front, right and left. So and this output will be shown in meter, ultrasonic meter. So these are the 3 meters. So these are the scaling factors we have used for scaling it. So now this is the light range. So for this also we use the scaling factor, and the light display, we are displaying the light, and this is a car headlight and proximity warning. If it is less than 100, this warning will be there, and based on this logic, car headlight will work. And so if there is any error, so this logic will work, and it will enable these bulbs, LEDs. So now we will move on to this motor speed. So based on this, so this k structure will work, and this scaling will work, and we will get an output, motor output string. So that string we are going to apply in the Arduino manually to control the motor. So now we will move on to fuzzy logic. So this is the fuzzy logic. So we selected the path already. So these are the inputs, light, all the ultrasonic sensor and compass and camera information, and which is given to multi input and multi output, and we are getting the output as car direction and car speed. In we are displaying it in front panel as a in meter. So this is a thing we are using for auto and manual control. So this is the steering. So we are getting the output manual direction control and manual speed control in kmph. So this is the overall stop button we have used, and this is the error check. We are generating error message if for the fuzzy logic. So now, so this point is just for the generating the magnetometer waveform based on the magnetometer inputs. So this is the fuzzy logic we have used. This is for the left sensor, right sensor, compass, front sensor, and camera information. So this is for the steering direction, and this is for a steering speed. So we have multi inputs and multi outputs. So we have written total 21 rules. So this is the test systems. So we can change the x-axis for left sensor, and right as per the rules. This will change the steering direction. So this, by this we can see the output here. So if we change this to compass, so again it will affect to the direction. So now we will take camera. Now we will take front sensor and speed. So here also if we change the range, the speed is changing. Now this is the front panel for the layman's car. So these three are the ultrasonic sensors, and these are the output as shown in the meters, and these are the error messages uh, uh, for the all the three ultrasonic sensors. So if we change the motor speed, so we are generating the character. So these characters we are displaying in motor. So these character is assigned with an ASCII value. So now we will assign input. So now so when we put the string values here, so ultrasonic front sensor, we got the output. So and the light level range also is changed, and car headlight is on. So and this is a stop push button to stop the process. So now we will move on to fuzzy logic. So now it is in auto condition. So now, initially, so when left sensor, it's like moving towards right. So and as for the fuzzy logic rules, this is operating. So so this is the compass towards west and towards east. So car direction is changing. So this is the camera information. We have 1 to 6 we have assigned in fuzzy logic. So based on each logic it's working. So and here we are using front sensor.
So this front sensor is just to control the car speed. So car speed is varying here. So when we change this to manual mode, so this is the manual steering, we can control both manual direction as well as manual speed.
So these are the values we have taken from Arduino magnetometer using potentiometers. So now we are going to process this, we are going to implement these values into LabVIEW to generate a waveform. Here we are exporting the magnetometer document what I explained before. So from here we exported this. So after exporting that data, so we are generating this graph for the magnetometer. Now we are using MATLAB version 22. So now we wrote the code for analyzing and training the images. So this is the code so which we have written to process an image, and we have to train the images. And these are the images we are going to process and train as per this software and the code what we have written. So when we run the training process code, so we are going to get this curve. So the first curve represent the accuracy. After this we got a 98.72 accuracy, and we reduced the uh, error to 0. So this is our curve. Now we are using another code to process the image. So we have 1 to 6, 1 to 3 for left, and 4 to 5 for 6, which is used in Arduino. So we are processing 5 fifth image, and if you run this image, so we'll get the output 5.